Right now, without moving, without thinking about it, your heart is beating somewhere around once every second. You probably haven't noticed it all day. It just runs quietly in the background, a small rhythm underneath everything else you do. One beat, then another, then another. In the time it took you to read those 3 sentences, your heart beat about 5 times. And here is where things get strange. If you had been alive for every single second of Earth's existence, all 4.5 billion years of it, and if each one of those seconds had a heartbeat attached to it, you would need to stack roughly 142 trillion years of human lifetimes, end to end, just to feel that many pulses. The math stops making sense almost immediately. That is the point. We were not built to feel this kind of time. We were built for seasons, for lifetimes, or for the span of a civilization at most. The universe does not care about any of that. Think about the oldest thing you have ever seen with your own eyes. Maybe it was a tree. Some of them live for thousands of years. Maybe it was a cathedral, 500 or 600 years old, still standing. Maybe it was a fossil locked in stone. Whatever it was, it felt old, ancient, out of reach. Now consider this. The light currently entering your eyes as you read this page left the sun 8 minutes ago. The light you see when you look at the night sky left those stars anywhere from 4 years to thousands of years ago. The Andromeda Galaxy, which you can spot with the naked eye on a clear night, appears to you exactly as it looked 2.5 million years ago, before humans had even invented stone tools. You are not looking at the universe as it is, yet you are looking at the universe as it was. And even that, even 2.5 million light years, even the entire age of our species, is nothing. Less than nothing. A rounding error in a calculation so large the numbers lose their meaning entirely. The universe is approximately 13.8 billion years old. That number is real. It has been measured, cross-checked, confirmed through multiple independent methods. It is not a guess. But here is the problem. 13.8 billion is just a number until you feel it. So let us try. If you compressed all of cosmic time into a single calendar year, a device popularized by Carl Sagan, still the best way to feel this. The Big Bang happens at the very first second of January 1st. The Milky Way forms in mid-May. Our sun ignites on September 2nd. And the first complex life on Earth does not appear until mid-November. The entire reign of the dinosaurs, 165 million years of it, fits between Christmas and December 28th. And humans, modern Homo sapiens, our full species, appear at 11:52 p.m. on December 31st. All of recorded history, every empire, every war, every book ever written, every song ever sung, every person who has ever lived and loved and suffered and died. All of it fits inside the last 10 seconds of December 31st. 10 seconds. You are not old. You are brand new. You barely arrived. And the universe was already ancient before your species learned to make fire. But here is what nobody tells you after they hand you that number. 13.8 billion years. They never tell you what comes after. Step outside on a clear night, far from city lights, and look up for a moment. What you see is a sky full of stars, thousands of them, visible to the naked eye. And it feels permanent. It feels like it has always been there and always will be. It has not always been there. For the first 380,000 years after the Big Bang, the universe was so hot and so dense that light itself could not travel through it. The entire cosmos was a blinding, opaque fog of plasma, like the inside of a star, except everywhere, in every direction, with no edges and no outside. There was no sky. There was no dark. There was no space between things, because things had not formed yet. Then it cooled enough for atoms to assemble for the first time. Hydrogen, the simplest element. And the universe, suddenly transparent, released a flash of light that has been traveling ever since. We can still detect that light today. It is called the cosmic microwave background, and it arrives at our instruments as a faint hiss of radiation, a whisper from the first moment the universe became visible. We are listening to an echo from 13.8 billion years ago, and it fills the sky in every direction, invisible to the eye but measurable, real there. After that first flash, the universe went dark. No stars yet, no galaxies, no light sources of any kind. Cosmologists call this the cosmic dark ages, and it lasted for roughly 200 million years, a span of time 50 times longer than everything that has existed since the extinction of the dinosaurs. And the universe spent it in total darkness, gravity slowly pulling hydrogen into clumps. Those clumps pulling each other closer, heating from the inside out, until finally, somewhere around 400 million years after the Big Bang, like the first stars ignited and the lights came on. Those first stars were enormous. We are talking about objects perhaps hundreds of times more massive than our sun. Monstrous, blazing things that burned through their fuel in just a few million years and then exploded, seeding the early universe with heavier elements. Carbon, oxygen, iron. The building blocks of everything that was going to come later, including you. Every atom in your body heavier than hydrogen was forged inside a star that died before the Earth existed. You are made of stellar debris. That is not a metaphor. That is chemistry. Now the scale begins to grow in a way that resists understanding. Our sun sits roughly 26,000 light years from the center of the Milky Way. The galaxy itself is about 100,000 light years across. When if you shrunk the Milky Way down to the size of North America, our solar system would be a single grain of sand somewhere in the middle of Kansas. And the Milky Way contains somewhere between 200 and 400 billion stars. But the Milky Way is not exceptional. It is an average galaxy. The observable universe, the portion of space from which light has had enough time to reach us, contains an estimated 2 trillion galaxies. 2 trillion. And each of those galaxies holds, on average, hundreds of billions of stars. The number of stars in the observable universe is roughly 10 times greater than the number of grains of sand on every beach and desert on Earth combined. Stop for a moment. Not to move on to the next fact. Just to sit with that for a second. Every grain of sand, every beach, every desert, every dune, every shoreline of every ocean on this planet. Multiply it by 10. That is how many suns there are within the observable universe. And we can only observe a fraction of what exists. This is where the floor disappears. Because the observable universe is not the whole universe. It is only the part we can see, limited by the speed of light and the age of time. The actual universe, if it is finite at all, may be vastly larger. Some models suggest it is at minimum 250 times wider than what we can observe. Others suggest it is effectively infinite. We do not know. We may never know. And that uncertainty is not a gap in our knowledge waiting to be filled. It may be a permanent boundary, a wall we built ourselves by existing in a universe where light has a speed limit. The universe does not care that we cannot see it all. And yet, even this, all of this, the 2 trillion galaxies, the uncountable stars, the dark matter threading through it all like an invisible skeleton, even this is not the gut punch moment. Here it is. The universe is not just big, it is expanding. And the rate of that expansion is accelerating. Right now, the most distant galaxies we can observe are receding from us faster than the speed of light, not because they are moving through space, but because the space itself between us and them is stretching. Those galaxies are not going anywhere. Space is growing between here and there, and it is growing fast enough that the light those galaxies emit today will never reach us. It is already lost. The observable universe is shrinking, not tomorrow, not for billions of years. But the process is underway, when driven by something called dark energy, a force or property of space itself that we have detected but do not understand, that makes up roughly 68% of everything that exists, and that is slowly, methodically, pulling the universe apart at the seams. Every galaxy cluster beyond our local group is already moving away from us faster than light, already unreachable, already cosmologically gone. And as time passes, more and more will cross that threshold. The universe is becoming lonelier, which brings us to the question nobody wants to ask out loud. If it all started with a beginning, if there was a moment, a real moment, when time itself was new, then what comes at the end? The last star will die, not our sun. That happens in about 5 billion years. First, it will expand into a red giant large enough to engulf Mercury and Venus, and then possibly Earth itself. Then it will shed its outer layers, leaving behind a white dwarf, a dense, hot remnant the size of a planet, slowly cooling into the dark over trillions of years. Our sun's story is ordinary. Every star in the sky is telling some version of it. But eventually, all of them run out. Cosmologists call the era we are living in the stelliferous era, the age of stars. It began about 100 million years after the Big Bang, and it will end somewhere around 100 trillion years from now, when the last small, dim, red dwarf star finally exhausts its hydrogen and goes cold. After that, there will be no new stars. The raw material for star formation, the clouds of gas and dust, will have been used up or scattered beyond recovery. The process simply stops. 100 trillion years sounds like forever. It is not. And if the stelliferous era were one day, 24 hours, then the current age of the universe would be about 2 hours after midnight. The sun forms at roughly 6 a.m. Earth forms shortly after. Life appears around 7:30 a.m. We are sitting here right now at about 8 in the morning, and the last star dies at midnight. After midnight, what remains is called the degenerate era. White dwarfs and neutron stars drift through absolute darkness. There are no new light sources, no warmth, no chemical reactions of consequence. Gravity still operates, still pulls matter together in the dark, but there is nothing left to ignite. This era lasts not trillions of years, but something closer to 10 to the power of 40 years, a number with 40 zeros after it. Written out in full, it would not fit on this page. And then even the white dwarfs decay. The protons, the fundamental building blocks of every atom, every molecule, everything you have ever touched, are predicted by some theories to be unstable over incomprehensibly long timescales. If proton decay is real, then matter itself dissolves, atom by atom, over timescales that make the age of the universe look like a camera flash. The rocks, the planets, the dark stellar remnants, all of it eventually unmakes itself. What remains at the very end, and this is real physics, not speculation, extrapolated from what we know about black holes, thermodynamics, and the behavior of energy, are black holes, and even they go. Stephen Hawking showed mathematically that black holes slowly radiate energy in the form of particles, a process so slow it defies intuition. A stellar mass black hole takes 10 to the power of 67 years to evaporate. A supermassive black hole, like the one at the center of our galaxy, takes somewhere around 10 to the power of 100 years. A googol, a number that has no physical meaning outside of mathematics, because there are not that many particles in the observable universe. The last black hole evaporates, and what is left is a universe at maximum entropy. The same temperature everywhere. No gradients, no structure, no information flowing from one place to another. Thermodynamics tells us that work requires a difference in temperature. Energy must flow from hot to cold to do anything at all. In a universe at maximum entropy, there is no hot. There is no cold. There is only an unimaginably faint, uniform warmth, a temperature almost indistinguishable from absolute zero. But not quite there, because zero is a floor the universe may never fully reach. Nothing moves, not because things are held in place, but because there is no reason for anything to be different from anything else, no gradient to drive a process, no energy differential to cause an event. Physics still operates, but physics has nothing to operate on. Time continues, if time even remains meaningful in that state. But nothing changes. It is not darkness. Darkness implies an absence. This is closer to nothing having a shape or infinity having a texture. Language does not reach it. The universe ends not with violence, but with silence. Not with a final explosion, but with a final equilibrium. The most complete, most total, most absolute stillness imaginable. And then that stillness, forever, masked and somewhere in the middle of all of this. Somewhere in the 14 billionth year of a story that may last 10 to the power of 100 years and beyond. You exist. You with your heartbeat, your 10-second slot in the cosmic calendar, your brief, improbable, unrepeatable moment of being aware that any of this is happening at all. The universe does not notice us. It does not need to. It will go on without us, in total silence, for longer than we have words to measure. But we noticed it. And that might be the strangest thing that has ever happened.